Okay, so this is our next notes in Algebra 1. Our last lesson for 4, we looked at scatter plots and correlation. And here we're going to look at correlation and causation. Whenever we have a scatter plot with just a graph that has a bunch of points on it, and we can put a line of fit in there kind of to show the behavior. And if you remember, there's also, like, if the points are going up or if our line is going up, there's a positive correlation. If they're going down, there's a negative correlation. But here we're going to talk about something called causation along with correlation. And one of the reasons to use a scatter plot would be to see if we can figure out something from our data. So really, you see this first line here. It says interpreting data on a graph. And that's really what we're going to do here. We're going to look at our data, maybe put a line of fit in there, and see if that data can tell us something. And maybe even answer these two important questions. First of all, is there a correlation? So does it increase, does it decrease, or maybe there's no correlation at all if the points are just scattered. The correlation we're also going to look for is some kind of relationship that exists between the data. So if one of them is going up, is the other one going up? If the other one of them is going down, is the other one going down, and so on. That's a good thing to look for. And also this causation part, are the data points we're looking at related to each other or dependent upon each other? So like whatever we put on the x, does it cause the y to change? Because you remember we have an independent variable and a dependent variable. Usually the independent variable is on the x and the dependent variable is on the y. And sometimes we can look at that data and see if there is one is affecting the other. Sometimes we might think it is, and then when we graph it, it's not. So if we're looking to determine in a scatter plot, is there a correlation and is there a causation, there's some steps we should follow. Okay, to do that, if we just have a bunch of data points, we can then first create the scatter plot. Then we look for the positive, negative, or no correlation in the data points. We may even put a line in there if we think that is warranted. And then once we see that if there's a correlation, we can then ask ourselves, is there a causation? Or if there's not a causation, and maybe it seems like there's a causation, one is causing the other, we have to ask ourselves, is that really true? Are there some other factors at play? And can this one factor really affect the outcome of the other? The main thing we want to remember with all this is if we see a correlation between the data, that does not mean causation. Just because one goes up and the other goes up does not guarantee a causation. We really have to look at the type of data and other things as well. Causation, though, if you remember from the definition, I just want to make sure you have this in your notebook. So causation, that is where one variable directly causes a change of the other. So let's kind of look at an example problem so we can get an idea exactly an application of this and how this looks. So here's an example. So let's say we have the Humane Society, and we're looking to see if there's first a correlation, and then if there is there causation. But here we have these 5 months at the Humane Society, and we want to ask ourselves, because we have number of dogs, and these are number of dogs adopted, number of cats adopted, is there some kind of correlation that we can graph on here to see if there's a correlation, and then ask ourselves, once we see is there a correlation, does one cause the other? Okay, so that's going to be our steps. We're going to take this data, then we're going to graph it, then we're going to see if there's a positive and negative correlation, and then ask ourselves a causation. So let's see. Let's first graph. So here's the graph I made. Here I got number of dogs on the bottom, number of cats. I use kind of the same scale. Add that one. So by 20 I'm going up. And we just need to take our data that we had. So in January we had 90 dogs. Looks like about here. And then about 124 cats. So about 90, 124, about here. And then we have 54 in February, so about there's 40, there's 50, somewhere around here, 54 and 72, so we just go up about there. And then we're going to go 62 and 85, just pretty close to here. Looks like about here, 62, 85, 39 and 53, about there, and then 85 and 121. There's 80, 85, somewhere about here. So there's our data that we have, and so we graphed our data, right? And then we look for a correlation. So if we look at our data, we could even put a line in here if you wanted to. You don't have to, but you can see our data goes up. So that tells us there's a positive correlation. So we graph, we ask ourselves, is there a correlation? There is. And then it's causation. So you really have to ask yourself, so as one goes up, as the number of dogs goes up, so does the number of cats given away or adopted. And you might say, how could one cause the other? Could that be possible? It's most likely not possible. So causation, we might say, does the number of dogs adopted affect the number of cats? We might say, probably not. Okay. If it's just based on one on the other, we could say, what are some other factors? So maybe the reason these dogs, the adoption of the dogs go up, and this is where you have to kind of think about it. So maybe there's some things like maybe the reason more dogs are being adopted is because they're having some kind of special event, and because there's more people there, both more dogs and more cats are being adopted. Or maybe there's an advertising campaign for a dog and a cat, like adopt a cat or adopt a dog, or something else like that. But you would think usually just a dog being adopted should not really affect the number of cats being adopted. The only way I could think that there could be a causation is if people go to the Humane Society to adopt a dog and there are no dogs because a bunch have been adopted, maybe then people would then adopt a cat instead. And somehow maybe that could be a causation, but probably not likely. So that's one example of how to go through this process. And remember again, the process is looking for causation, but you create a scatter plot, you look for the correlation. Here we saw the correlation. It's a positive correlation. As one goes up, so does the other. But then we ask, is there causation? And we just look at the data. It's not always something you can determine just by looking at the data. But here, you probably think, there's probably not a causation between the number of dogs adopted and the number of cats. And I'm going to show you one more example to help you out here, and then we'll be done with the notes. So here we have another example of looking for correlation and causation. Here we have this gentleman, Lane. He works as a cook. And this graph, this data table here shows the months he worked, the hours he worked, and the pay he earned. So really this data table is the number of hours worked and his monthly pay based on those hours. So again, the steps are graph the data, then look for a correlation. Then if we have a correlation, is there causation? And let's graph. So here's the graph I have. I have hours worked on the bottom. This is kind of what you control. And then based on the hours you work, the independent variable, you get a dependent variable, the pay you receive. It's going to be different based on this one. So the hours worked control how much pay you receive. So then if I take my data, we go back and look at it, and we see, so for May, 17 hours, and then made about $150. So go about here, we'll go about there. And then in June, go back, 51 hours and about $450. Just 50, 51, go up to about there. So there's that. And then go back to July. Got about 49, a little bit less than 50, and about 430. So we go on this side. 430, there's 450, probably about there. And then August, we have about 43 hours and about 375. So there's 40, about 43. We're looking for 375. There's 350. Probably about there. And then we have September, about 30 hours and about 260. 30 hours. There's 250. 260. About there. And then September, okay, we got that. September and October, 31 hours and about 270. There's 250. So right about there. There's our data set. We can see then if we draw a line, right? So then we have our data set, right? Graph the data, look for a correlation. It's going up. As one goes up, so does the other. So we got a positive correlation. Okay, and then we got causation. And causation is, does one thing affect the outcome of the other? And you could probably say, yeah, because the more hours you work, if it's based on the pay, how much you're paid per hour, then your pay increases. So we'd say yes, causation. And we could say it's based on its rate of pay, more hours means more pay. We could also say maybe more hours means more tips if you're like a waitress or a waiter or a bartender as well. So there most likely is some type of causation there. So there's the two examples. I hope that makes sense to you. This is lesson 4.5. You can ask me questions in class and we can go over any of these if you want to.